Honors Math 2, Unit 11. Unit 11, in my opinion, must have been one of the hardest tests for all of you because it had the lowest average of all the tests in second semester. Which surprises me because I thought, it had something to do with, trig, like 7, 8, and 9, when we talked about unit circle or graphing of trig functions and stuff like that. That and the proofs, those weren't the hardest. The hardest was 11, which dealt with graphing quadratic functions, solving quadratic functions, knowing the different forms of quadratic functions, where the vertex is, does it open up, does it open down, and then even solving quadratic functions. So let's go through these things. Hopefully, if you this is a gray area, I'm hoping to highlight the things that you need to remember. If not, remember there are always videos that we have way back there that you can look at as well. We first learned something called vertex form. When we learned Unit 11, vertex form was a way for us to figure out where the vertex was and whether it opened up or down or wide or narrow or normal, depending on how it was written. The first thing, I'm going to put vertex form next to this. If you don't remember vertex form, it took on this shape. Y equals A parenthesis x minus h squared plus k, where the vertex would be at h comma k. This is the vertex. That's the lowest or the highest point of the parabola. And the interesting thing about the vertex is since the formula had a negative h, and we over here where the vertex is a positive h, this you were supposed to remember was opposite. Because this is a k and that's a positive k, this was the same. If we remembered opposite same, we could know what the vertex is without doing any work. If I'm looking at 71a and it says graph f of x is equal to x plus 2 quantity squared minus 3, this is in vertex form. I know what the a value is. The a value is a1. I know what the h value is. Negative h, change the sign. Opposite of this would be negative 2. Same as this would be negative 3. The vertex is at negative 2, negative 3, which is right here on our graph. Because the a value is a positive 1, that must mean that it opens up. And we can tell if it's wide or narrow based off of its a value. I told you back then that if you went to 1 to the right of the vertex and up 1, and to 1 to the left and up 1, that you could tell if something was wide or narrow depending on what this number was. If it was 1/2, you'd go to the right 1 up 1/2, to the left 1 up 1/2. If it was a 2, you'd go to the right 1 up 2, to the left 1 up 2. And it doesn't work that way all the way down, but the first single unit will work something like that. So I'm basically making a sketch beyond those 3 points. That's what our graph is going to basically look like. It's a normal sized parabola. The domain is all real numbers. What does that mean? That means that I can plug in anything I want for x. I can plug in x is 0, I can plug x is negative 2, I can plug x is positive 2, I can plug all the way up to 100 or 1,000,000, and I'll get a y value when I plug in any x value. The range, on the other hand, we only use certain y values. There are y values that we're using, but they have to be bigger than negative 3. So what do I write for the range? The y's are going to be greater than or equal to negative 3. The line of symmetry is asking for what is the name of the line that cuts this parabola directly in half? And since it's a vertical line, it should be x equals h. Whatever h is, it's x equals a negative 2. It's called the line of symmetry, or some textbooks call it the axis of symmetry. Lastly, it asks, is this a max or a min? Since there's only a lowest value, we're going to say that it is a minimum. There is no maximum. It goes up forever and ever and ever in both directions. So there is no maximum, there's only a minimum. If the parabola was going downward, there would be a maximum. So that's a review of vertex form. You're going to do the same thing for part B. I'm not going to do that one with you. You guys will get the chance to do part B on your own. When we look at vertex form reveals a couple things. It reveals what HK is, otherwise known as your vertex. That might help you when you're getting to the second part of 71. 72, on the other hand, is different because it is now in standard form. When something's in standard form, it is written as y is equal to ax squared plus bx plus c. This is not vertex form. I don't know what the vertex is. The only thing that standard form reveals really easily is the y-intercept. It really does. The y-intercept is the easiest thing to figure out because it's the c value and the y-intercept are going to be the same thing. So I'm going to jump down to part B and put down the y-intercept's the easiest thing to see in standard form. What they ask us to do is they ask us to fill in a chart here going from -4 to +4. Plug in those values and plug in the chart. In this class, sometimes it's when I have to do a table, I love taking shortcuts, and you could plug in 4 and do 4 squared minus 2 times 4 minus 8 and figure out that, and you could plug in 3 and do 3 squared minus 2 times 3 minus 8. But because I'm going to be doing so many different things, you don't need to know how to do this. For me, I'm using a table function. I'm going to use a table function on here, and I'm going to plug in x squared. Calculators are great as long as you know how to use them. And if you don't know how to do this, don't worry, you're never going to be asked it. I'm just going to show you that it is capable of doing it. I can type in my equation. X squared minus 2x minus 8. I can even type in a second equation on some calculators. I'm not going to put one there. I want to start at -4. I want to go to +4. And I want to count by ones. I want to step every step by 1. -4, -3, -2, and so on. And what this will do is it's going to actually do every single calculation for me. -4, the value is going to be 16. -3, the value is going to be 7. -2, the value is going to be 0. And I'm just going to keep scrolling down and fill in this chart. Kind of nice to be able to use the technology to help you find all the values real quick, because that's not the important part. Calculator helped me fill in all those values. I'm going to go graph it real quick. 4, 0, 1, 2, 3, 4, 0, 3, -5, 1, 2, 3, 4, 5, 2, -8, 5, 6, 7, 8. I'm going to go off the graph. 1, -9. I'm going off the graph. 0, -8. I'm going off the graph. I probably should have counted by 2s now that I look at that. So I have this parabola that opens up and looks something like that based off of these values. And the vertex is going to be that lowest point. The lowest it gets is right here. This is my vertex, 1, -9. our axis of symmetry would be at x is equal to that, goes right through there, x is equal to 1. Scoot that over a little bit. And there was a formula that we could use to figure out what that axis of symmetry is. Another little thing that you had to remember. And I'm curious if you remember what the formula is. It would be what on top? Say it out loud if you know it.
B.
Ooh, close.
Negative B over 2.
Negative b. Over?
2A.
2a. Hey, awesome. It's the first part of the quadratic formula, if you didn't know. And so, negative b over 2a can be used. If I know what this is, I can do the opposite of this divided by 2 times a value.
I don't need your sign.
Thank you.
Bye.
And so, the other thing that we can do here is find the x-intercepts. Where does it cross the x-axis? The y value would equal 0. I can see the 2 x-intercepts here and here. I'll put them in order. Negative 2, 0 is smaller. 4, 0 is larger. So I'll do that. It asks me to factor. So I'll factor it to x minus 2, or I'm sorry, x minus 4 times x plus 2. That looks like it works. And then it asks a question, what is the relationship between the factors and the x-intercepts? What's the relationship between this factor and that intercept, and this factor and that intercept? You don't need to say, let's just write it down. The factors can be set equal to 0 to find the intercepts, the x-intercepts. Let's be more specific. They reveal the intercepts when it's in factored form. This is actually called intercept form. They're going to ask you a question about it down here in part F. In intercept form, it reveals your x-intercepts. So then, we talked about vertex form, we've talked about standard form, we even talked about intercept form. Then they threw in some extra stuff in here that you may have forgotten called translations, but you definitely learned it last year. If your sketch r of x has x squared is a parabola that goes through 0, 0. This is r of x. Just goes through 0, 0. It's a normal parabola. If you were to sketch a translation such that all the x's and y's are going to be transformed by moving the x's plus 3 and the y's minus 2 to create t of x, well, what does that do? That means that you're adding 3 units to your each x value, and you're subtracting 2 from each y value. Imagine you have a 0, 0. Where is 0, 0 going to go? You're going to add 3. 1, 2, 3, and you're subtracting 2 from the y. Your 0, 0 will become 3, negative 2. Well, what happens to 1, 1? You add 3 to it. 1, 2, 3, and you go down 2. What happens to negative 1, 1? You go add 3 units to it. You go down 2. You can kind of just see that this new graph, t of x, is a translation of the first graph to the right 3 units and down 2 units. You'll answer some other questions about when the graph is decreasing. It's getting smaller when the x's are blank compared to 0, and when it's increasing, you're going to figure out what goes there. I picked 2 on 75. I picked part B because of the negative that's going to happen here. If I was doing this problem, the first thing I would look for is a GCF of 75. I feel like a 3 goes into there. Let me see. 3, 25x squared plus 16 equals 0. I would try a GCF factoring first. I might divide by 3 and divide by 3 just to get 25x squared plus 16 is equal to 0. Now it looks like a difference of squares, but it's not. It's a plus, so I can't use factoring difference of squares. So what I'm going to do is I'm going to subtract 16 to the other side. And I'm going to divide by 25. And I'm going to get x squared is equal to negative 16 over 25. This is called solving by square rooting. I'm going to square root. When you square root a variable squared, it's the same thing as the absolute value. You are not allowed to square root a negative unless you use the imaginary letter I. Now you can square root to 16 and you can square root to 25, which comes out to be 4 over 5, and then I'm going to put I behind it because we write numbers then letters. The absolute value of x means that there are 2 possible answers for this. X is going to be equal to plus or minus 4 over 5 I for our final answer. Sometimes your answers are going to deal with a complex letter I. For part E, what I decided to do is say, well, what happens if you can't? You try to factor it. If it doesn't factor, then you either need to use the quadratic formula or complete the square. I'm going to try to factor this, and we're going to hope for the best. Let me see. 2 times 1 is 2. 18 times 1, 9 times 2, 6 times 3, or vice versa. 3 times 6, 2 times 9, or 1 times 18. I wonder if there's a way to get to negative 15. Let's see. There's 12 and 3. Maybe that'll work. Maybe if I use this one and this one. Maybe if I use the 6 here to get to negative 12, and I get to 3 there, and I make negative 3x, that might work. Let's see. Negative 12, negative 3, negative 12, 13, 14, negative 15. Bless you. Negative 3 times negative 6 is positive 18. It does factor. Some of these will, and some of these won't. If it doesn't, use the quadratic formula. Or complete the square. This times this equals 0. Now I could use the zero product property, which says either this factor has to equal 0 or this factor has to equal 0. In this case, x would be 6. In this case, x would have to be 3 over 2. So what I did back in the day was I would write my final answers for this as an ordered pair. Not an ordered pair, I'm sorry. A solution set. That's why these brackets are curved. 3 over 2 or 1.5. And 6 are my 2 solutions or possible solutions for that. Bless you. Yes, sir.
What's the equation for completing the square?
I would say go back to your notes and take a look. It's not an equation. It's a process. It's where you move the C value. You factor out any A value. You add half of B squared to both sides. You factor, square root both sides, whole system. Take a look at it. If you don't know, go back into the notes for completing the square. I want to say it's 11.4 notes. The last problem I'm going to go over with you is 76, and I thought about doing some other ones, but instead I'm just going to show you part D. Part D has 7 over 5 minus 2i. Because it's a binomial in the denominator, you cannot have a square root in the denominator. The only way to get rid of this I value is to multiply by something called the conjugate. When you multiply by a conjugate, because we're dealing with a fraction, we have to multiply the same thing to the top and the bottom of our fraction. I'm going to multiply by 5 plus 2i to the top and 5 plus 2i to the bottom. The numerator would be 7 times 5 is 35, and 7 times 2i is plus 14i. The denominator, though, if you FOIL this, you have 5 times 5 is 25. 5 times 2i is plus 10i. The bottom would be negative 10i, and those would just cancel each other out. And then negative 2i times positive 4i would be negative 4i squared. Something happens with that. Anytime you have I squared turns it from the square root of negative 1 times the square root of negative 1 turns it into negative 1. And you're multiplying that. It's going to change this negative 4 into a positive 4. So what do we do with that positive 4? It goes with the 25. 25 plus 4 is 29. Sometimes this will reduce, sometimes it doesn't. For me, I usually will split these two things. And I would accept it as a fraction over a common denominator, or I would accept it split as well. The reason why I split is because sometimes it will reduce on one part or the other, and I'm just checking to see if it does. There's lots of other questions, but I'm hoping that reminds you of the major ideas.